Hello and welcome to my shop, and thank you so much for joining me here today. It's July 30th, almost the last day of the month, and I'm starting on this fantastic Philco radio. This is commonly called the Philco Hippo radio. I'm not so sure, it looks like a hippo to me, but maybe in some way. And there's a number of these models. So this is the 48460 version of this radio. What a fantastic looking radio. I just love the curves on it. They're fantastic. And the condition of this particular one is fantastic also. You know, Bakelite radios are really holding up well if they're taken care of, and to take care of them you don't do much to them. But there's no warping or anything. They look really fantastic. You know, this is from 1948. So, you know, how long ago is that? That's 50, 60, 70. 75 years ago. Wow. And this is a strange part. Look at the back of this radio. The back looks, look how flat it is. It just doesn't look believable. I've almost never seen a radio with a back in this kind of condition. It's fantastic. I see some clips down here, and I see some plastic someone's put inside. The word I got from the owner of this radio is they themselves have never plugged it in, and they bought it from somebody who never plugged it in. See on this cord, you see quite a few loose strands of wire here. And eventually they'll come out, get around like this. Somebody's going to grab this plug. We're going to go for a ride. Okay, so we're going to fix that a little bit. The cord itself is very flexible, so I wonder, you know, is this original? I don't know if that's original or not. And I don't know if this back is original or not. If it's original, it's fantastic that it's survived this far. So it's in some grooves here. So exactly how you get this out, I don't know yet. Okay, it's almost certainly screws on the bottom. Let's tune this guy. Can you see the tuning thing move? Look at that. Isn't that cool? That is really cool. And the tuning feels great. It feels really great. Oh, that's probably that bag in there. Plastic bag in there. And on off, no tone control. Well, so I can see the antenna now running right in here. So the antenna is actually glued on the inside of the cabinet. It's not on the back. Ooh, that's a thumbs up. An awful lot of radios of this age have lost their back. And some of them, the antenna is on the back and it goes too. And the antenna is an important part of the radio. It's not just the antenna, it's a tuned antenna, tuned specifically for this radio, based on the number of turns and other things that are associated with it. That antenna is really important. So luckily in this radio, it's right in the cabinet. It's not going to get lost, even if the back is a replacement, which I was kind of worried about. Let's take a look underneath here. Now, a few things. If this is the first video of mine that you're watching, you'll have already noticed I don't edit very much. I don't edit it really at all. Oh, look at that. We got ourselves a bit of information here. So these tubes, if you notice the numbers, maybe you can't quite see it, but 7B7, 7B7, 35 Wi-Fi, 50L6. These 7 tubes, 7C5, and this 14 one, which is 7 twice. These aren't 7 volt tubes, they're 6.3 volt tubes. The number 7 indicates that these are Lochtel type tubes, and they're designed to, when you put them in, they click in, they lock in. You can see 3 screws holding the radio in. Still worried about the back here. I think these clips are just sitting in here. I don't think they're doing much at all. There we go. Okay, so much for the back. Well, it's in perfect shape. Look at how clean it is. A little worried about seeing these bags shoved in here because of light wires, like these wires up here that you can see are very light. These are probably going to the antenna. Yeah, they are. So you could snag these easily. In the dark you wouldn't even see them and pop them off. Yes, you can always put them back on, but the challenge is where did they come from? If you find them already torn off. There's the model number there, 48460-121. Another big long number. A whole bunch of patents. Some small sticker. None of these things I can read. Guess what? I'm going to the optometrist today to order my new glasses. So I'll be able to see. I will be able to see soon. So I can see a wax capacitor right here. I can also see the very curious, wow, I'm glad he didn't try taking the chassis out of this right away. A very, very curious arrangement here for the tuning. There's an apparatus up here, spring, and then there's a string pulling on this. There seems to be a clip arrangement here. The string appears to be clipped in, and there's probably a calibration issue. If you take the chassis out, this isn't coming with you. This has been screwed in up to the top here, I guess, somehow. Something going on there. Big piece of thick plastic here. And the light, probably trying to beam into this plastic. And the plastic probably conveying the light out this way. Like the last thing they want is a hot spot of light on here. That will ruin it. They want it to be cast out. So that's how they've done it. Looks to me like the light is a little low in here. No, there's another piece. There's another piece here. Let's see if we can get a little closer look. Very interesting what they've done. Hard to see, but this thing I'm pointing at here, it's a large piece of plastic, and at the end of it is the pointer. So they're trying to get the light from the light bulb to go into the end of this piece of plastic, go through the plastic, and light up the pointer as if the light bulb is in the pointer. At the same time, they're trying to get light to go into here, this big piece of plastic here, to just generally cast the light. And these radios, these lights are usually very dull. They're not very, there's not much light there. I would say to take this out, they have to release this clip, release this string, lose the calibration, perhaps even have the string drop off this wheel here, which I don't really want to have happen. I think I better find the service manual. There may be special instructions on how to take this out. There may be some trick that I've never seen this before or dealt with it. Look at this. So these knobs up here, down here, the knob, this knob here, is attached to a long shaft that runs all the way down to the radio where the control must be located. And then this one, can't really see what's happening, but maybe it's gear driven. Oh no, no, there's a string in there. Could be the same piece of string. I don't think so though, because I see this string is kind of a light white color, and there's another dark one going over it right there. You can actually see it hopping over the white one. That shouldn't probably be happening. So this string is the drive string. What a complicated arrangement. Especially this apparatus here is really quite something. That's probably why they made so many of these. They had to make millions of them to get their money back on them. The speaker appears to be, it's a big speaker in there. Big oval shaped speaker. Appears to be right on the chassis. So we take the chassis out, speaker comes with it. If I try taking the chassis out without dealing with this thing. This spring-loaded part is going to want to go all the way over here. You can't see how you take this out and maintain this string connection. It's got to go. Okay. So another thing, if you're a first-time viewer, you've now learned I don't edit very much at all. That means that while I'm doing this work, I may say things that I think are true, but they aren't, or I may misspeak. I do that. Sometimes I meant to say red, but the word black comes out of my mouth. I don't even know it. When I'm working on the radio, I may get caught up in something that's of interest to me, maybe not of interest to you, that I want to pursue and investigate. I may make mistakes or not realize something, and that may go on for a while you, as a viewer, may have realized right away what has happened. Jim, you dropped it in there. Didn't you see that? No, I didn't see that. So eventually I do get around to sorting things out, so it seems. So not to panic if it looks like I'm going down the wrong road for a while. This is really very much live TV. Yes, it's not live in the sense that I'm here right now, you're watching a video, but in terms of scripting and knowing what's coming next, no, I don't know what's coming next. Actually, I do know what's coming next. I'm going to go drink some coffee for a little bit, and we're going to try to find a service manual and then take this guy apart and look inside. I wouldn't want to take a radio like this and plug it in just the way it is without examining it a little further. I mean, it looks like it's in great shape, so my guess is you could plug this in and it would work. And we're probably going to find this out after I drink some coffee. So what I'm doing is I'm looking for hints on how to take the chassis out of the cabinet. It's kind of obvious as it looks to me, but I'm just looking for hints. So I found the service manual. It's on Radio Museum. I'm a member of Radio Museum, but the thing about Radio Museums, stuff like this, is it's page by page by page. So if you're going to download a whole service manual of 10 pages, that's 10 downloads. So I've only downloaded this page. There's no instructions in here on how to take it apart, but there's some very interesting stuff in the Philco service manual here. There's only one thing I really want to show though. It's on the next page. You know what? It's on the first page, Jim. It was on the first page. Go back. Right here. This last paragraph. Right here. This is just under circuit description. The two series resonant circuits, C304 and C305, function as bypasses of exceptionally low impedance. Ha ha ha. What is it about a capacitor that gives it exceptionally low impedance? Well, C304 is resonant at 455, and C305 is resonant at the second harmonic, 910, which is double 455. How do they do that? How do they make these capacitors resonant? They have a coil wrapped right around them, or inside them, sort of. You can't see it when you look at it. First time I encountered these a few radios ago, first time I encountered it and realized what I was encountering, it turned into a little bit of a mini disaster for me. So I don't want that to happen here. What I did in the other case was I removed the capacitor, had no idea what I was doing, took it apart, found this coil inside, kind of slapped myself in the forehead, oh my, and I ruined it at that point. I don't have such capacitors, who would? Some guys will rewind them. If you got the right size wire and that, you can kind of rewind the coil around the capacitor. Other instructions are, don't worry about it, just put a capacitor in there and move on, because this exceptionally low impedance thing is not all that important to the operation of the radio. And that's what I did in the last case. This case, I'm just going to be a lot more careful because I've discovered this exists already with these two special capacitors. I believe that's what they're typically called, special capacitors. So, but as for, there's lots of, this is a really great service manual here. You know, to avoid possible damage to the radio, the following preliminary checks should be made. Now, in other manuals, they would say, the following preliminary checks should be made, but they would never say this, to avoid possible damage. So the person who's writing this is really trying to clue you in on not only what to do, but why you're doing it. So it's really great. I'm not going to read through it right now, because really all I'm interested in knowing is that I have it. And yeah, lots of interesting stuff here. Troubleshooting assistance. We don't know that we need to troubleshoot. What I think we need to do is take that radio out of its cabinet now. I'm going to have to just wing it, I guess, on what to do about the tuning thing. So we look closer at the tuning thing here, and what I've noticed about it. So it appears to have a clip here that you could just lift up with your finger and the string would come off. And the string appears to be clipped in there. There's no knot, there's no mark. Oh, I could put a mark on it. There's nothing to tell you where the string, how tight the string should be. I should put a mark on it. Good idea. Yeah, man alive. You see what coffee can do for you? Actually, coffee doesn't really doesn't spark you up, doesn't wake you up. Coffee keeps you from getting sleepy. Well, if I put a mark on the back of the string, that won't help me in the end. I won't be able to see it. So I'm just going to mark it like this. Oh yeah, that's marked. But I bet there's a procedure, an alignment type procedure for ensuring that this is restored properly. So I think if I just pick this, pull this forward, the string's just going to come out of there. Oh, the string has a shape. Yeah, the shape marks the spot. You know, after being like this for 50 years. Okay, the string is out. The string is out, yeah. Yeah, you can look at the shape of it. And I have nice blue marks on it. Very good. Don't want it to fall off here. But actually at the moment it's held by the other string. Particularly if I turn this way. This other string, which looks like a piece of wire in fact, is clamping this string in that position. Good. Okay, I think we can, yeah, we can lay this guy down on his front and take these guys off. That's not a quarter, is it? Yep. Model 48460, code 121. Yeah, Philco company was consistent in how it numbered radios and that for a long time. So where I used to work, we used a lot of drawings. We had a lot of engineering drawings, hundreds and hundreds of them. And the numbering system wasn't just 1, 2, 3. It was codified, so we could read the number and understand things just from the number. And part of that was putting the initials of the person who authorized the production of the drawing. Anyway, just to say, in some cases you got a stupid number, in other cases the numbers mean something. Like tube numbers actually mean something, but they're not consistent enough to really pay attention to it. Now, how do I get the knobs out here? Ooh. So it looks like it pulled the knob out and the shaft stays, when it's low enough it'll slide out. It's hard for you to see in there, I mean. So we'll try lifting the knobs off here. This does look like the original cord too, power cord. Oh yeah, wait a minute, something's coming up. Well, the whole radio's coming up because I unscrewed it. Yep, there it comes. There we go. It's just a regular knob with a spring clip. Ooh, what do we do about this antenna? The antenna's not coming out with the radio. The wires are long enough, you can swing out the radio chassis and keep the connections. There we go. Now these are still sticking up. They're sticking up through the hole here. Well, I guess I have to tip and draw the radio out this way. But if I do that, I'm going to break these wires. I better photograph this. Get a good image of it. Now you know what? I can photograph it right with the camera you're looking through. So let me just take a snap here. 1 second while I remember how to do that. And we want to put this, oh my gosh, I gotta save it in the right spot here. I apologize for this while I play around with my computer. Into the Philco folder. Philco. That starts with a P, doesn't it? Philco. And the Philco 4860. Save that. So I've saved an image showing the location of these wires. I'm looking myself now. One goes here. Oh, it looks like somebody's unsoldered these previously. We're going to try to leave them connected. Final inspection. Who did it? 722. Mr. 722 inspected this thing. I think I got other things in my house that guy's inspected. You can see I'm taking my time here. Okay. A little bit at a time. I wonder how many times guys have designed radios like this and then they get to the cabinet stage and at that point they find out they can't put them in or out of the cabinet. What's this? This is the light. The light's got to come on. There we go. Okay, I've got it out. Longest shaft on a volume control I've ever seen. Wow. Radio's super clean. Where's this radio been all these years? Wow. Super clean. Now I can lay it face down on its speaker, oddly enough. I think that's probably one of the safer ways to lay the radio. Let's try that because we want to look underneath. Wow, it looks like it's brand new underneath. Oh, it's all... My gosh, somebody's already done it all. It's all been done. Fantastic. There's no wax capacitors left in here. It's a lovely job done here. The person who did this is a little more professional than me. I have to admit. Although I don't normally put this kind of capacitor back in. I put a different type of capacitor back in. So this guy's sitting here. That looks like an original. Great big original. Well, there's no reason not to turn this guy on because I betcha it works. Could be there's absolutely nothing here for me to do except be the first guy to turn it on. While. Okay, I do want to fix this this plug situation here before I plug it in. But first, time for some more coffee. So I started taking the plug off here to fix the loose strands when my eye just traveled down to here and I looked a little closer and this has exposed copper right there. So gotta go. So this cord's gotta go. Plug can stay. The cord's gotta go. So maybe I can just shorten this up. Yeah, maybe that's a good thing to do. Try to maintain the original. What I imagine to be the original plug is probably isn't, but I don't know. It looks original anyway. But this is no good. This is bad news right here. Okay. That's just a slightly bigger job now. Hey, something to do. Yeah, the last guy left me something. Great. And I'll bet you this is a replaced cord. Okay, let's just nip it off here. I don't think I'm going to video this whole action, but I'll get you bigger cutters. Let's not work in the dark. Let's do it here. Wow, that sounded like it fractured more than it cut. This is probably very stiff and hard here. And it just fractured when I squeezed on it. Okay, I have to go find a cord now. No, I'm going to use this cord. If we're going to use this cord, then we need to take a look at the schematic a little bit and consider the way in which the chassis is connected. Now, I think I read somewhere there's a resistor connecting the chassis to the B minus point. And so what I'm doing is I'm looking for anything that is soldered down to the chassis. Now a lot of these tube sockets have chassis terminals, if you like. So I'm looking at those two to see if any one of them has been used. Actually, it's only this one tube socket that has that. So, you know, here's the B minus. Look, it looks like he's glued this in. What's this black stuff? Black one to here. Here, 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 here. And I'm just not spotting a resistor tied to the chassis. It might be on a terminal strip here. So the terminal strip, yeah, here it is, right here. So this particular part of the terminal strip is going right down to the chassis. You see it's riveted? This other one has no connections to it. There's two places where the terminal strip is riveted to the chassis here. So this, where's the resistor they were talking about? So this is really important to look at, because if I determine that this connection is the same as this connection, then this is a hot chassis radio in the real sense of it. If you plug this plug into the outlet, well, maybe not this one anymore, but plug it in one way, everything's fine. Plug it in the other way, 120 volts sitting on the chassis. It also said something in there about resistor was to keep a hum down, and it also said there was, maybe I was reading another reading about another radio. I seem to have some recollection about a phono connection. There's no phono connection in here. I am looking at the radio now. So you see he's replaced a lot of parts. All these mica capacitors, perhaps these are. He's replaced a lot of parts in here, the last guy. I assume it was a man. Shame on me. Could have been a woman, but if you had to bet. So, you know, that's the only thing I can see. I can see the connection coming straight back, straight, curved, around here to here, here to here, here to here, and then coming all the way back to here. So I really think maybe I was misled by what I read. This is a hot chassis cab radio, I believe. Oh yeah, don't tip it up. You gotta change the cord. Let's look at the schematic and see if we can really see it on that. The schematic. Where are you? The schematic is on another page here. The schematic is right here. Here we are. Lots of information on this schematic I can see already. This whole line up here showing the amount of amplification taking place at each stage. They're including that information. They must be including a lot. Here we are, right here. This is exactly what I'm looking for. Chassis. Oh, these are these special capacitors. That's right. That's right. Oh, he's gone and changed them out. It's probably what's happened. So let's see where. So this is it. This is connected to the B minus line, and they're using this ground symbol, which is a little bit confusing. But this is not to the chassis. This is to a piece of wire. The black wire you saw me tracing through the radio. That's what this is. All this stuff is all the black wire. The black wire. This, on the other hand, is the actual metal chassis. You can see there's a connection here, out at the very front end of the radio. And then we have these guys who are connecting the B minus line to the chassis through a capacitor with a coil. And looking at the capacitor, you wouldn't be able to see this. So this is 18 and this is 40. How's that going to help? I need a diagram showing me the location of these components. Okay, I'm going to stop for a bit and look for that diagram. Okay, so the parts we're looking for are part number 18 and part number 40. Let's go looking. Part number 18, part number 40. Here's 18. It's a big guy right here, just above the big capacitor. Here's 40. Ay, looks like it's buried under here. Boy, this radio looks a lot more complicated than the one I've got on my bench. But I mean, that's because he's replaced so many capacitors. It's actually neatened it up. Some smaller capacitors. What is a schmozzle in here? Okay, so we're going to look at the radio and compare it to this diagram here. Okay, you can see the diagram and the radio below, and obviously you can landmark this big capacitor. Right above it should be the number 18, which would be in this position. And here you see what has to be a new capacitor installed by the last guy. It's only going from here to here, and hard to see if that's exactly the same connection. So let's see, this one's coming up. Yeah, it looks like it's going to the same place as up on the diagram. The other one we can't really see. It does look like it's heading this way though. So I think this is the replacement. This is a 0.25, and now I can't remember the, just hang on a sec. Let's just take a look and see 0.25. So if it's this, which one are we looking at? We're looking at number 40, wasn't it? We're looking at number 18. Okay, so we're looking at number 18. Number 18 is this one. It's a 0.15 with a coil. And what's in here now is a 0.25. And I assume no coil in here. The coil is not a straightforward coil in these things. It's a trickly wound coil. So these special capacitors, they're not a small deal. That's what I would say. Can't remember the details of what I'm talking about. I just remember they were just not a straightforward coil. So the other one was down in this area, number 40. Let's look again at the diagram. So number 40 appears to be pointing at a capacitor that's buried under the wires going this way. That's what it looks like. And this would be a similar sized capacitor to this one. So I have a big bulky thing, and you can kind of see that there's a bit of a space in here. You could have a capacitor. I see a small one sitting here. So assumably the last fellow just replaced these with ordinary capacitors. He may or may not have realized the story with them. And he may have understood that the minor improvement that these provide the radio, the coil, not important. So he may have been very consciously putting in these capacitors, and don't worry about that Philco special Philco capacitor thing. Can we operate this radio? Yeah, as soon as I get this cord in there, I'm sure we can operate this radio, and I bet you it's going to work. Okay, so I got to get back to fixing this cord and doing that stuff. Now, if you're watching my videos and you're seeing me fix radios, you're probably pretty much good at fixing a plug. I can see the basic mistake the fellow made who did this. It's just too much wire. It's too much bare wire. You tried to wrap it around and around under the screw. There's no need for that. Just bring it around like this and then cut the excess off. And I mean, it's not like you're powering a nuclear submarine through this connection here or something like that. You don't need it to be. You don't need so much copper under the screw head. These old plugs often also have a cardboard cover that fits on top, because even after I do this, it's still not too tough to get a shock. Okay, so I'm trying to tuck the wire up underneath. The other thing is, when you put a wire under a screw, you can put it under this way, or you can put it under that way. You want to put it under the way the screw tightens down, because it'll pull the wire under the screw as you tighten it up. If you do it the other way, if you wrap the wire the wrong way, as you tighten the screw down, the screw will push the wire out. You'll end up with a mess. And it's just that these, you know, again, if you're watching my videos, you probably know all this stuff, but maybe not. Okay, so just get rid of this excess wire here. So also, you bring the wire up. I can't do it with this one because it's got quite a knot in there, but you bring the wire up. You have a choice now to bring the wire around here, or to bring the wire up through here and around here. So this particular plug, because of its funny shape, doesn't make much difference really which way you do it. You're probably better off to come up through here. But on the more around plugs, or typical plugs, then I think it's more important to pay attention to that. Because again, what you're trying to do is keep all the wires under the screw. Where'd that come from? See, as I tighten this down, it'll pull the wire under. Now there's no free ends to slowly work their way out and show up on the outside of this plug. The problem with this plug, of course, I mean all plugs, you can do this, yow, or you can get your finger under. I guess you can't. It's pretty tough to touch that screw, but I mean you'd have to really put some effort into it to try to shock yourself with it. But okay, this guy, let me just extend this a little bit. Here. Now, you might say, oh, which wire goes where? So that's the whole thing about this radio. It's an unpolarized plug. You can plug it in the outlet this way or that way. One lead will contact the hot side of your power system, and the other lead will contact the grounded side of the power system. Hot, grounded, not the best terms, but I think it gets the point across. Since you can't control which way you're putting this in, can actually if you just mark it and think about it, but you essentially don't know or are not controlling which one of these is hooked up to the B minus and therefore to the chassis. Wait a second. Hold the fort. Hold the fort. I am seeing a solid wire connection to the chassis. The two special capacitors are missing. I'm assuming this is the replacement for one. Maybe that's not what happened here. Maybe the guy solidly grounded it. No capacitor, no protection, no nothing. And really opened this radio up to the hot chassis problem. Some radios are like that. They're right out of the factory. The B- is connected solidly to the chassis. But I guess sometime after that, probably after shocking a number of people, they started trying to isolate the chassis away to some degree using a resistor, capacitor. They still want the chassis connected to the B-, just not so solidly. That way, if you do get a shock, the current flow is limited and the shock can be called a brush shock or something like that. You're going to get a mild shock instead of getting a full whopper. They're dangerous. Shocks at 120 volts are dangerous. They kill people. So this is serious business here, especially in the modern world where nobody knows anything about these things anymore. The chassis, all that stuff. Nobody knows. I don't think anybody really knew about it in the first place. But you know, back when these radios were put on the market, nobody realized what was going on here, except for the engineers and hobbyists and people like that. How many people got hurt by these things? Today what people do is they get a radio like this and they decide, hey, let's hook up our Bluetooth to it. Well, I wouldn't do it to this kind of radio. First, I'd find a radio that's got a phono plug on the back of it. I'd say, okay, this one's probably safe to do this with. And any radio that does not have a big power transformer, any radio that's got series tubes, any radio that would be classed as an all-American 5. I hate to say that because Canadian radios were built the same way. You need to be pretty careful. Okay, I'm going to finish the soldering of that wire, and we're going to fire up this radio and find out if it works. I'm sure it does. I'll be shocked if it doesn't. Interesting to find out how well it's aligned. That might be interesting. Coffee now, though. Okay, a couple things before I start this up. The radio's in unknown condition, really. Looks great, but maybe there's something about it that isn't so great. I don't know. Am I going to plug this right in the wall and turn it on? Probably not a good idea. The risk is low, and what is the risk? The risk is setting something on fire in the radio, which is really not very likely. Tripping your breaker on your house, well, it's not the end of the world, but it's a bit of a hassle if you go into the dark. The worst case would be you plug it in the wall, you turn it on. There isn't such a short circuit in here that it's going to cause your breaker to operate or fuse to blow on your house. And in my case, I have a number of smaller fuses and circuit breakers in line with the supply. But even those, if the problem in the radio doesn't draw enough current, they won't activate. And whatever it is that's drawing the current, just keep drawing the current. And eventually, whatever it is going to get hot, and it's going to burn out. And it could be any one of a, could be a minor component, who cares? A resistor, who cares? Or it could be something big, like not in this radio, but other radios have a big power transformer that you don't dare ruin. So what are you going to do in a case like this? You want to plug this in and somehow restrict the amount of power that's going to come to the radio initially until you feel more comfortable with operating it. So the way I do that is I use what's called dim bulbs, a dim bulb system. It's just putting old incandescent lights in series with the radio's power supply. So the power that gets to the radio has gone through a light bulb on the way there, which sounds kind of weird, but actually it works really well. These radios typically are 40 watts, something like that. So if you were to put a 100-watt light bulb in series with it, you'd probably end up with maybe a third of the power in the light bulb and 2/3 in the radio, something like that. So my light bulbs are right here. If you watch lots of my videos, you know all this. I'm talking to somebody who hasn't watched any of my videos yet. So I have two light bulbs. The light bulbs are in parallel there, but they're in series with this. I have a super duper control panel here with 2 switches on it. The panel's off right now. This is the main on-off switch. If I push this button down, then power comes to this outlet on my bench through those light bulbs. If I throw the switch up, the power comes straight from the Niagara Falls generators, straight into here, straight into the radio. So at that point, if something's really wrong with the radio, I just plug it in. I don't have the dim bulbs in. I could cause the water to reverse at Niagara Falls. I don't want that to happen. So, because they'll figure out it's me. So first I'm going to put it on like this. These lights are going to come on. The radio's going to start. Things are going to happen. I'll tell you what the pattern is in just a moment. And based on the way the lights operate, I can actually assess the condition of the radio to some degree. So what is going to happen here, let me just flip this back up. What's going to happen here is I'm going to turn the power on. The tubes are all cold, the heaters are all cold, their resistance is low because they're cold. A lot of current's going to flow in. Well, the current's flowing in, it's going to be enough to light up the light bulbs. I'm going to start with just one light bulb. I'm going to unscrew this one. All the power will be forced through this. This is a 25 watt light bulb. So as the heaters heat up, they draw less power, the light goes down. This can take 10 seconds or 2 seconds. It all depends upon the bulbs I'm using and the kind of radio here. This radio's got 6 tubes in series. This should be a really good radio. In fact, it has 6 tubes. I'll explain that somewhere down the road. But once the heaters have heated up, they begin heating the cathodes in these tubes. The tubes that have cathodes, I think they all do. And that takes a little bit more time. Once the cathode is hot, the tube begins to conduct, the radio draws more power again. So initially, rush into the cold heaters, high power, comes down, heaters heat the cathodes, tubes start conducting, power goes back up. That's exactly what the light should do. Come on, go down, and come back up. It might take quite a while with just one light bulb in because the power is so restricted. It takes time for everything to happen. We will watch these lights. Now what happens if I plug this in, turn the power on, the light comes on full tilt? Well, then I know there's a short in here. That's the whole deal. And in the camera, what you're going to see is not very good. The camera can't handle this. Your eye is a fantastic thing that can see very little light, even in the face of a lot of light. It's amazing. Your dynamic range of your eye is really great, much better than the cameras here. So you're going to see. So I'm going to see something different from you. So first, we turn the set off. This is to test the off-on button, so the set is off. So nothing should happen here. So I'm going to put the power on. See, no light in the light bulb. You might have seen this meter jump up here, but this is really the one to look at. 118 volts. But it's going nowhere because the switch is off. Okay, so power off, switch on, volume down. I can turn the volume actually up about that far. I don't remember seeing any filter capacitors. Oh yes, I get what am I talking about? Great big one in there. What am I talking about? Okay. Hit the switch, watch the light. Here we go. Bright. It's going down, it's going down, it's going down. At the same time, this voltage should be coming up. 45, 48, 51. That's very low. 53. Take a long time to heat the tubes up this way. You can see the light has come on a little bit. 63. The radio won't operate with, gotta have at least like 90 volts in that range. 68. So what this is telling me is everything's okay. The light is not on bright. It's behaving normally. So I'm going to screw the other light bulb in. This will jack the voltage up to almost normal. The radio's coming on. 110 volts. Okay, that's plenty. Well, that sure sounds like a radio to me. Now, a little secret I didn't tell you about. Oh, I forgot to throw a switch. So This guy operates with this antenna. That's good. Back here I have this loop. This loop is attached to an outside and active antenna. So the loop will provide some signal for the radio to pick up. That's the theory. Except I forgot to turn the switch. Turn it on. But let's just try this. Just checking for hand effects. I don't see any. Volume going up and down a little bit. Here we go. $20 per month on Rogers Internet for back to school. Visit Rogers.com for details. We got you. Rogers. Well, that pretty much tells the story right there. Accessibility for the 1 in 4 Canadians living with a disability. Rick Hansen Foundation. It's without boosting. Oh my gosh, really? Without boosting.
That they're not made to have a reverse onus. They're just as dangerous as somebody walking down the street with a gun.
Hey, they're what?
John Dunright, your renovation destination.
French. Looking for a French station. This radio's working really good. Excellent. It's working excellent. What am I supposed to do with a radio that works excellent? Put it back in the cabinet. Send it on its way. You know, the one thing I did do is I replaced the dangerous cord, the deadly cord. Alignment, all that stuff, with it operating like this, I'm kidding myself to fiddle around with it. Better to just leave it all alone at this point. So the happy news for the owner of this radio is they can turn it on and play it. And I better cut the power off here before I give myself a shock. Good. I'm going to stick it back in the cabinet. And we'll have one last look at it. It's a one-day wonder. Okay, it's middle of the afternoon now, and time to give this radio a test here. Let's see how it works. Okay, so power's on. Here we go. Let's see how much light. Let me darken that room down a little bit here. Actually, quite a bit. Ooh, that's a lot. Here we go. You say the light in a radio like this behaves similar to the dim bulbs I was talking about earlier, and for similar reasons, kind of. Lovely. Look at that. So now the camera's doing some funny things here. Saw the color just change a little bit there. So, but with my eye, the lighting of this dial is beautifully uniform. It's really quite impressive. And then the pointer, you can see it's just beaming out here.
It's not good to lock pitching. Pitching is almost half of the game. You need way more of this than they have. That to me is clearly the difference.
I think it's an interesting transition into Ricky Tiedemann news. I know this was a couple days ago, but I was away, so I'm going to ask you now.
So
it's a 640.
That might spur you to do things.
From a traffic
680.
along, is one from the traffic working again from the garden.
740. I have a booster coil going here with outdoor antennas, so I'm going to bring it up closer. Oh, some lightning there. That was a bit of lightning. There's a rainstorm coming.
Get down, I'll give you a break.
820.
Donc j'étais vraiment
860.
derrière le nez. J'apprenais le...
970. Yep. Yeah, jump in volume. You can't see it. I got my hand on the volume control here. That's 1010. Bit of parallax in the dial. It looks like it's not quite at 1010, but that's 1050. It's 1150 next. And I don't know the stations from here on up. They're all... Very good. Works really good at the low end. Much better.
The Dow is higher by 181, so we're seeing
Let's put some lights on.
momentum to the upside in the Dow now. The S&P still in the red, it's down 33, and the Nasdaq still the worst performer today.
Well, that's
It's
wonderful.
down 209.
That's a wonderful
That's a
radio.
drop
The
of 1.2%.
last person who worked on it did a nice job on it, and pretty much all I did was put a new cord on and make the radio a little bit safer. Not much more than that. Fantastic. Okay, I got to come up with another radio. I got to bring one in that's in bad shape here, because I've had a couple of fairly good shape radios go through. Time for a bad shape one. How about an old one? How about an old one from the 30s? Yeah, that sounds like a good idea. Well, thanks a lot for watching this video. I was going to say series, but it's only one video. And this really wonderful radio. Have a good look at it before it goes away. Look at that. Oops. Lovely. See ya.